United States Department of Labor, OSHA, enacted a law called Hazard Communication, commonly referred to as Right to Know, which deals with the safe handling of chemicals in the workplace. This law requires manufacturers and importers of chemicals to provide health hazard and physical hazard information for the chemicals they sell. This hazard information is supplied on a special form called a material safety data sheet. Manufacturing companies that use chemicals are required to make their workers fully aware of the hazards outlined on these material safety data sheets. Manufacturing companies are also required to provide workers with the training and information needed to safely handle these chemicals. Manufacturers, distributors, and importers of chemicals are also required to properly label each container of chemical they produce or sell. For the purposes of the Hazard Communication Law, a container is defined as any bag, barrel, bottle, box, can, cylinder, drum, chemical reaction vessel, storage tank, or the like. The labels must be legible, in English, plus other languages if desired, and prominently displayed. In addition, the identity of the hazardous chemicals in the container must be given unless it is a mixture of chemicals protected as a trade secret. The health hazards and physical hazards of the chemical must be listed so you can adequately protect yourself against them. This warning may be written or displayed as pictures or symbols. A label on an incoming container can't be removed or defaced unless it is immediately replaced with another label that contains all of the required information. Likewise, a container doesn't have to be relabeled on arrival if it was properly labeled by the manufacturer or importer. There are some exceptions to the labeling requirements of the Hazard Communication Law. Pipes and piping systems are not classified as containers and do not have to be labeled. Signs, placards, process sheets, batch tickets, operating procedures, and similar written materials can be used in areas containing multiple stationary tanks that contain similar materials instead of labeling each stationary tank. Portable containers, such as safety cans and bottles, which are filled from labeled containers and will be used immediately by the person who filled them, do not have to be labeled. Hazardous wastes and certain other chemicals are exempted from the requirements of the Hazard Communication Law. This training program is designed to provide you with the knowledge you need to handle chemicals safely. It consists of three parts: the health hazards of chemicals, the physical hazards of chemicals, the material safety data sheet. You should familiarize yourself with the material safety data sheets for the chemicals you work with and gain a thorough knowledge of their particular health hazards and physical hazards. All chemicals pose some degree of health hazard. The degree of hazard is directly related to how toxic the chemical is and how much of it you are exposed to. For example, over the course of a year, most of us eat more than 1 pound of salt without any serious health effects. However, if you would eat 1 pound of salt in 1 hour, you would probably die. Similarly, if you would drink a half gallon of liquor in 1 hour, you would probably also die. The effect of chemical exposure can be classified according to length of exposure or dose received as either acute or chronic. Usually, acute effects are the result of exposure to high concentrations of a material for a short period of time, while chronic effects are the result of repeated exposure to low concentrations over a long period of time. Acute health effects are those that appear during or shortly after an exposure. A burn from a concentrated acid splash would be an example of an acute effect. Chronic effects are those that appear long after an exposure or after repeated exposures to small doses of a material. For example, many employees who worked with the carcinogen benzodine developed bladder cancer many years after their first exposure. In order for a chemical to have an effect on you, you must be exposed to it, and some of it must get into your system. The most common route of entry for chemical substances into the body is through inhalation or breathing. Gases and vapors in the air you breathe can pass into your bloodstream along with oxygen. Small solid particles can also be inhaled into your lungs. The next most common route of entry for chemicals into the body is absorption through the skin. Many solids, liquids, vapors, and gases can be absorbed through the skin. The third common route of entry for chemicals into the body is ingestion or swallowing. We usually don't intentionally swallow the chemicals we work with. However, failing to wash your hands before eating, drinking, and smoking can result in the ingestion of chemicals. The fourth common route of entry for chemicals into the body is injection. In the workplace, chemicals are injected when they enter the body through broken skin, such as cuts, sores, burns, and scratches. Therefore, it is doubly important to use gloves and other protective clothing when handling chemicals if your skin is broken. Some of the more serious health hazards that chemicals may pose can be classified according to the way they affect the body. Carcinogens are chemicals that have been found to cause cancer or are suspected of causing cancer. Most chemicals are classified as carcinogens based on the results of experiments with animals, since human data is usually not available. Corrosives are chemicals that may cause burns. The burns may not appear immediately after contact. Strong acids, such as sulfuric acid and muriatic acid, and strong caustics, such as caustic soda or sodium hydroxide or ammonia solution, are examples of corrosives. Irritants are chemicals that may cause reddening, swelling, and pain short of actual tissue destruction. Sensitizers are chemicals that may cause an allergic reaction after one or more exposures. Once a person becomes sensitized, a very small dose of the chemical may cause a big effect. Many chemicals are classified as toxic. The toxicity of a chemical can be measured using a variety of animal studies. OSHA considers a chemical to be toxic under the hazard communication law if small doses killed half of the rats tested in what's called an oral LD50 test. If the rats used had each weighed 165 pounds, they would have had to swallow individual doses of anywhere between 0.132 and 1.32 ounces of the chemical to kill half of them. A chemical is also considered toxic if small doses killed half of the rabbits tested in what's called a skin LD50 test. If the rabbits used had each weighed 165 pounds, it would have taken individual doses of anywhere between 0.528 and 2.64 ounces of the chemical applied to their skin to kill half of them. In addition, a chemical is considered toxic if it killed half of the rats who breathed it at concentrations between 200 and 2,000 parts per million, or 2 and 20 milligrams per liter, in what's called an inhalation LC50 test. 1 part per million, or ppm, is equal to 1 part of chemical mixed with 999,999 parts of air. In many cases, a chemical will pose physical hazards to workers as well as health hazards. The material may be very flammable or may react violently if combined with other materials. Flammable liquids are liquids having flash points below 100 degrees Fahrenheit. Many of them can be ignited by a spark without any preheating. Examples include acetone, methanol, and toluene. Flammable liquid spills should be treated with particular care, since large volumes of flammable vapors may be formed. 1 gallon of any flammable liquid can give as much as 600 gallons of pure vapor on evaporation. Combustible liquids are liquids and liquid mixtures having flash points at or above 100 degrees Fahrenheit. Most combustible liquids can't be ignited by a spark without being preheated. Examples include O-dichlorobenzene, fuel oil, and nitrobenzene. Oxidizers are chemicals that contain a lot of oxygen and may start or assist the burning of other materials. Examples include chromic acid, concentrated nitric acid, and potassium permanganate. Oxidizers and flammables should be kept away from each other. Mixing the two together may cause a fire. For example, potassium permanganate dampened with glycerin will burst into flames in a matter of minutes. Water-reactive materials are chemicals that react with water to give off a gas that is either toxic or flammable. For example, calcium carbide will react with water to form flammable acetylene gas. Material safety data sheets can help you identify the health hazards and physical hazards of the chemicals you work with. A material safety data sheet should be available for each hazardous chemical or mixture used in the workplace. Section 1 of the Material Safety Data Sheet lists the name, address, and emergency telephone number of the manufacturer, distributor, importer, or company that prepared it and the date it was prepared. The identity of the chemicals must be listed unless trade secret protection is claimed by the chemical's manufacturer, importer, or distributor. Section 2 of the Material Safety Data Sheet will list the hazardous ingredients in a mixture of chemicals unless trade secret protection is claimed. Section 3 of the Material Safety Data Sheet lists the physical and chemical characteristics of the material. The boiling point of the material is the temperature that the liquid must be heated to in order to make it boil. Generally speaking, the higher the boiling point of a liquid, the slower it evaporates into the air, and the longer it takes to build up a toxic or explosive concentration. The vapor density of the material is a measure of how heavy the vapor from the material is compared to air, which has a vapor density of 1. Vapors that are more dense than air tend to accumulate close to the floor and in low spaces. The resulting higher concentrations near floor level and in low spots can present toxic and explosive hazards. The appearance and odor of the chemical describes what the material looks like and smells like. This information can be helpful in identifying the material if any of it is spilled or released into the work area. Section 4 of the Material Safety Data Sheet lists the fire and explosion hazards of the material. The best firefighting materials to use to put out a fire involving the chemical will be listed. Very often, more than one type of fire extinguishing material is listed. With some chemicals, special foam extinguishing agents and personal protective equipment may be required. Section 5 of the Material Safety Data Sheet lists specific health hazard data for the chemical. In order to understand the allowable exposure limits for a chemical, you must first understand the concept of time-weighted average, or TWA. Your time-weighted average exposure to a chemical is your total exposure to the chemical for the workday divided by 8 hours. Even if you work longer than an 8-hour day, only 8 hours can be used when calculating your time-weighted average exposure. Here are 3 examples. First, imagine drinking 8 beers, 1 per hour for 8 hours. Second, imagine drinking 2 beers per hour for 4 hours, followed by 4 hours without any beer. Third, imagine drinking 8 beers in 1 hour, followed by 7 hours of regrets. In each of these examples, you would have consumed a total of 8 beers over an 8-hour period. Your time-weighted average exposure to the chemical beer would have been 1 beer per hour in each case. However, the effect of the chemical would have been different in each case. You would have built up a much higher concentration of alcohol in your bloodstream if you drank the 8 beers in 1 hour. Consequently, you would have experienced a much more noticeable effect from the same quantity of alcohol than if you had consumed or been exposed to it at the rate of 1 beer per hour. However, in all 3 cases, you were exposed to a time-weighted average of only 1 beer per hour. This example also illustrates the difference between chronic and acute exposure. Exposure levels for many chemicals have been established and are expressed as 8-hour time-weighted averages. They may be called threshold limit values, or TLVs, or permissible exposure limits, or PELs. These values will be listed on the material safety data sheet. For most chemicals, you can be exposed above the listed value so long as your 8-hour time-weighted average exposure is equal to or less than the number listed on the material safety data sheet. The known acute and chronic health effects and related health information for the chemical must be provided in this section of the material safety data sheet. This includes whether the material is considered to be a carcinogen. This section of the material safety data sheet also provides information on the expected routes of entry and symptoms that might result from an exposure. Any medical conditions that might be aggravated by the chemical must also be listed. Emergency and first aid procedures are also included. They will explain what to do in the event of an exposure. Section 6 of the material safety data sheet explains the reactivity of the chemical. Many chemicals react violently when mixed with other chemicals. For example, oxidizers and flammables may ignite when mixed. Materials that are incompatible with the particular chemical will be listed. Section 7 of the material safety data sheet outlines emergency spill and leak procedures. Whenever chemicals are spilled or otherwise released into the workplace because of leaks or other causes, special procedures must be implemented. In the event of a spill or release of chemical into the work area, you can use the appearance and odor information found in Section 3 of the material safety data sheet. However, odor is not a particularly reliable method of detection. Not everyone can smell a given chemical. Those people who can smell a given chemical have different sensitivities to it. Some can smell it at very low concentrations, while others can only smell it at high concentrations. Also, some chemicals deaden the sense of smell after a few whiffs and are no longer detectable. Hydrogen sulfide is a highly toxic gas that deadens the sense of smell. Personal protective equipment may be needed by those who remain in the area to clean up any spilled material or continue operations. The cleanup of a spill may involve the use of special equipment, such as absorbent materials and special techniques. Section 8 of the material safety data sheet outlines how exposure to chemicals can be controlled by the use of personal protective equipment, appropriate engineering controls, and through effective work practices. Since inhalation is the most common route of entry, properly selected respiratory devices will protect you from overexposure. Proper eye protection will protect your eyes from accidental contact with the chemical and loss of sight. Properly selected gloves and clothing will protect you from skin contact with the chemical while you are working with it. Section 9 of the material safety data sheet explains any special precautions that should be taken during the storage and handling of the chemical. For example, cyanides should not be stored next to acids. A spill of the acid could eat through the cyanide container and make deadly hydrogen cyanide gas. The material safety data sheet supplied by the manufacturer or importer of a chemical contains a wealth of health and safety information. You should study the material safety data sheets provided for each of the chemicals that you work with and follow their instructions. Your health, and maybe your life, depends on it.